right, so here we go with another proof using the quantifier negation rules and the rules from 7.2, and etc. So we have our conclusion is tilde for all x, bx. There's the bx predicate there in the first premise, so we know where it will come from. But we're not going to concern ourselves with that right now. We're going to try and get these premises to work together. To do that, right, we've got a's in both and c's in both. So it seems like they will work together at some point, but obviously given the quantifiers involved here, we're going to have to break these down a bit. Now, as you know, in 7.2, one thing we commonly did was we would take off quantifiers as our initial step. Well, we could take off this quantifier here from line number 1, but just note, in line number 2, we cannot remove this quantifier because the tilde is in the way. So in fact, before I pull off that quantifier, since I know I'm going to probably break this line 2 down eventually anyway, I am going to go ahead and move that tilde out of the way with the QN rule here, just so I can start to move in a direction that will allow me to break this down as well. And in fact, it was a very good idea to start by doing quantifier negation on line 2, moving the tilde out of the way so we can remove the quantifier, because now I will recognize that in fact, I definitely want to remove this quantifier here, the existential quantifier, before I remove the universal quantifier, right? Because you'll remember from 7.2, this little dictum, right, that I gave you, do EI first. Always do EI before you do UI. And that, again, remember, that's because you want the, to be able to have the letters match. And so if you do EI first, they will be able to match. And if you do UI first, they won't be able to match. And then you won't be able to, do other fun things, we could say. So we're going to do EI on line 3. And so that means we're going to choose a letter here and here, right? We're going to choose a couple letters. It cannot be a variable. Remember, when you're doing EI, you can't choose a variable, so they have to be individual constants, and also individual constants that have not appeared in the problem previously. Of course, you don't have any individual constants here, so you can choose any individual constant you would like. And so I'll choose a lowercase a there. All right, so we've got our our second premise here broken down to this. Let's go ahead now and go back to the first premise and break that down a bit. We can now do UI. And of course, when we're doing UI, we want to go ahead and match the letter we chose there when we did EI. So we're going to get AA dot BA horseshoe CA, and that's UI on 1. And so now we've kind of gotten it down to lines 4 and 5 here. These are, hopefully at some point going to work together. But if we think about them, there's nothing that's jumping out at me right now, right? We don't have a modus ponens sitting here, for example, enabling us to get the CA or whatever. So we're going to have to, we're kind of stuck, right? We can't get these to work together. We get kind of stuck. And when you get stuck, remember, that's when you want to turn to the replacement rules, right? The replacement rules. And so you want to choose whichever of these two lines looks most complicated and use a replacement rule on it. In fact, there are a couple options here to think about. We could, of course, use exportation on this and turn that dot into a horseshoe and then shift the parentheses over. That could be a good option. We might end up doing that. But I'm actually thinking, because I'm such a fan of De Morgan's, of turning this horseshoe into a wedge with material implication. And then that'll enable me to do De Morgan's and then maybe break it down in a good way. But the key point is do a replacement rule on your next step since you can't get these to work together. So first of all, I do implication on line 4 to turn it into that. And then I can do De Morgan's on line 6, right? Because I have a tilde outside the parenthesis and a wedge inside. So I bring that tilde inside to both parts, and that enables me to turn the wedge into a dot, right? So once I have that, And I'm still thinking, of course, about how can I use line 5, okay? I'm thinking, well, one possibility here would be to get the tilde CA by itself, and then maybe do a modus tollens with line 5, right? So, of course, to do that, I'm going to have to do commutativity on line 7 to move the tilde CA over. Then I can simp that line 8 to get tilde CA by itself. And now, looking at lines 5 and 9, right, so just focus on 5 and 9. Here's P, horseshoe Q, and tilde Q. Well, that is the setup for modus tollens. Giving us tilde A dot B by modus tollens. Now, at this point, since we've done all this work, we can kind of focus on, well, what do we want to get, right? We want to get the B by itself. And so there is the B inside those parentheses. Of course, the main operator of line 10 is the tilde, so we can't just try and simp it out of there. But perhaps, since we have tildes and dots, right, we'll remember De Morgan's once again. And so let's continue here with line 11. We can get tilde AA wedge, tilde BA by De Morgan's on line 10, right? We could do De Morgan's on that. I'll try and squeeze in here where you can still see me. So how do we get the BA by itself? Well, we'll need to get, right, wedge is the main operator. This is a setup for disjunctive syllogism. And so to do this, we just need to get the negation of the left-hand side. In other words, double tilde AA. There is double tilde AA right there on line 7. So let's simp line 7 to get that. And now comparing lines 11 and 12, that's P wedge Q and tilde P. We can get tilde BA by disjunctive syllogism 11 and 12. So we're getting there, right? We got this. We got the B by itself. Obviously, we have to add a quantifier here. And I would just note here, right, this is a long problem, right? We've been working hard, and I will just recognize that there's a temptation here at this point to say, oh, we're so close to the end, and some people might say, all right, we can just get this by universal generalization on 13. And here I definitely want to warn you, this does not work. This will not work for a couple reasons. First of all, you can't do universal generalization when you have an individual constant here rather than a variable. That's one thing. But even if I granted a special dispensation so that I'd allow you to do universal generalization on an individual constant, when you add on the universal quantifier, it never would get added between the tilde and the B here. Whenever you add on a quantifier, it always gets added to the far left of whatever you're adding it to. So this would not work. So don't let the light at the end of the tunnel, so to speak, blind you as to what you're supposed to do here. What we can do, we can't add on the universal quantifier here. We need to add some kind of quantifier. So instead of that, remember, you can always add the existential quantifier. That is always going to be true. You will always be able to add the existential quantifier. When you do, you add it to the far left, and then what do you know? Once you add it to the far left, we can just simply flip that tilde to the other side using the quantifier negation rules, and you get what you're looking for. You get your conclusion that we were trying to get. Okay? So work hard like this, but then remember, you can't add on the universal quantifier with an individual constant. You can always add the existential quantifier, but make sure you add it to the far left, and you'll still be able to get what you want thanks to the quantifier negation rule.